Hi folks, we're back in Mod 5 Novice Problems. We're going to look at problem number 6. Number 6 is a classification problem that we're going to work with the Excel Miner software. So let's get out of here. Let's go to our practice worksheet or novice worksheet. Let's go to our data. Our data is this credit approval data. Again, we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 variables, and we want to create a classification model from this history that we have of approval and rejection, so we can easily take a new applicant and then apply a simple rule, say you're approved or you're rejected. Automation of this classification process. As is always the case, we generally, if it's either always or generally, have to adapt the data that we have available for the purposes of our analysis. We have text here for homeowner. We have text here also for the decision. I'm going to have to convert that to a numerical value. Fortunately for us, there is dichotomous choice. It's either yes or no, approve or reject. So what I do is I grab my data and I move it over here to the right, and I've entered a new column called homeowner number and decision number. I separated out the old text, the text here for decision, and I'm going to get rid of this for a second just to show you how we do this. Obviously, we're going to need some sort of a function here. I want to put in a if function and say if whatever is in this cell is equal to y, then give me a 1, else give me a 0. So those are my classifications. Hit enter, and then I copy it down, and we get the right classification. Now, often when you're using programs, and you have a formula in a cell and you try to feed that program this formula, it doesn't like it. So I'm going to copy this area that I have here. I'm going to copy it. And then I'm going to do a special paste. I'm going to paste by value. So now I'm taking my formula and replacing it with a value. Now nothing should change. The numbers are the same. All I've done is replace that function with the values it would have given me. And I did the same over here with the decision. You can see these are just values. All right, now my data is ready to go. So let's go to Excel Miner. The first thing we do in a classification model is we partition our data. And we're going to partition the data in the data mining group, okay, not the time series group. So let's go to partition. We're going to do a standard partition. Then it wants to know where the data is. I'm going to we'll get rid of all of these here. I want to shuffle them back to where they were. So where's the data? Well, the data is located with a title in this range. Hit OK. And what should appear should be the 1, 2, 3, 4, 5, 6 variables that we've got. So I'm going to select these guys. This is what I want to do my classification with, these variables. I bring them over to this area. I pick rows randomly. I set the seed to 1, 2, 3, 4, 5 so I can retrace my steps and get the same order of random variables. Automatic percentages are left alone. This is essentially set for you. Hit OK. And what I have now is a data partition sheet that has been provided for me. And here's in the data partition, what we've done is we've taken some of the data, we create a model from it, and then we test it on another part of the data. We don't create a model with all our data. If we did that and tested it on itself, it's a bit of an incestuous process, and we might not find the problems that can occur with the data. So We grab data, we cut it into pieces. I say, I'm going to build my model with this piece, and I'm going to test it on this other piece of data. So now we got our data partition. All right, now in the problem, we have a number of records that we would like to classify. These are records that have just come in, requests for approval or rejection. So I can make the conversion again with the data from the Y to a 1 and to a 0, and I placed that data over here. I'm going to grab this data. I'm going to copy it. I'm going to go to my partition. That's where we're going to be doing our work in our partition. I left out the homeowner. It's okay. I can put it anywhere here. Oh, excuse me. I didn't leave it out. I'm sorry. Here we go. Now, things match and line up. This is a homeowner. This is a credit score. This is the number of years for the credit score. This is a revolving balance, etc. I'm going to copy these titles just to make sure that we haven't got a problem. Titles have got to be the same for the data that we had above this partition and this data below. Now notice what's missing is the decision number that's going to be determined actually. So now let's go to classify. We're going to use the k-nearest neighbors algorithm, and we're going to select the first 5 variables as our selected variables, and the decision number is what we want our output variable to be. In other words, we're going to take these and we're going to determine the decision based upon these 5 variables. I hit next. I want to normalize. This is a standard sort of a thing. I'm going to use the number of nearest neighbors to be 5. It gives it a wide variety of possible selections from 1 to 5. I'm going to score on the best between 1 to 5. So I'm going to pick the best of the neighbors, either 1 neighbor, 2 neighbors, 3 neighbors, 4 neighbors, or 5 neighbors. Leave this as it is according to relative occurrence. I hit next. I don't want all these reports. I simply want summary reports. I'm going to score the new data, which is in a worksheet, and it's going to ask me, well, where is it? So I'm going to, and this is an important step. Here's the data range where you're going to put the data. Say, here it is, including the decision number. And then I'm going to press this Match by Name button. So it matches the variables in our partition with the variables that we're asking about. I'm going to hit OK. It returns me to this third step. I hit Finish. And now we have a variety of outputs. Here's one important output. Here's the information regarding the various k's that were used. It appears that the best value of k for this rule is a single neighbor. So I take the data that I have and I find the closest neighbor, and I'm going to categorize this new record according to the categorization of the classification of that neighbor. If that neighbor is approved, it'll get approved. If that neighbor was rejected, it'll get rejected. But I'm only using one neighbor. All right, that's what this particular information tells us, and you find that in the validation error log for different k. Now there's another output here called new score. Now, what you have here is, let me widen this a little bit. What we have here is all our data that is going to be classified as either a 1 or a 0, the 6 records that we looked at, and here is the classification. The first one is classified. The predicted classification is going to be accept, the next one a reject, next one an accept, next one a reject, and an accept. These probability numbers tell us, what's the likelihood of either rejecting or accepting. And so we'll copy this, we'll paste it into our solution, copy it. I can go back here, and actually I've got that in this worksheet already. Here it is. So here's predicted classes. So the first record for the data that we had, let's go back and look at the data we wanted to predict. So the first one gets accepted, the next one rejected, accepted, rejected. And we can make the comparison of those, and we can see what the decision is going to be based upon on the outcomes that we determined in our analysis. Okay, so back to the problem. So this will be the decision number. Okay. The next question asks, what is the best K? Obviously, we found that in the K nearest neighbor classification scheme output sheet. We found it here. It tells us that that was 1. That's not always the case. Sometimes we have multiple neighbors, especially more complicated data, that allow us to categorize the data. So that is how we perform a data partitioning and then build a classification system, and then compare records to that classification system that will have a predicted outcome, whether they're accepted or rejected. That's the end of problem 6, module 5.